In section 4 of chapter 3, we're going to look at quadratic functions and applications. So what would be some examples of what quadratic functions look like? Well, they're in the function format, and of course it's x squared. This is quadratic. So it could be as simple as this, or a little more complex as a trinomial, or even a binomial. And remember, the letters that we use in function notation can be somewhat different. But we do have a standard form of these. That is ax squared plus bx plus c. And recall, if this y, we could substitute a y here, was 0, this would be in standard form of the quadratic equation. And you couldn't have a as a 0. This is a qualifier, because then it wouldn't be quadratic. So for example 1, we're going to start off looking at what do these quadratic functions look like when they're put into a graph. And what we need to do is sort of recognize the general shape of the graph based on what these equations look like. So we'll see this on the next page. So they have this all laid out here, but what we want to do is put this into a t-chart, which is sort of what's illustrated there. And we can go y equals x squared. So we put our values of x out here, and then now we're just going to square these. Well, 2 squared is negative 2 squared is 4, 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And of course that's what they have here. So when we plot this, we start with negative 2, we go up here to 4, negative 1, we go up to 1, 0 is 0, then a positive 1, and then a positive 2. Now as we look at this, we see we've made a particular parabola here. This is the shape of this curve. Now, a couple of things going on here. We'll also notice that right here, the y-axis divides the parabola into sort of reflective parts of each other. And if we were to fold the parabola, the graph, at this axis, these lines would coincide. So there is symmetry here. And we say the axis of symmetry, while it is the y-axis, what would the formula for the y-axis be? And the answer is x equals 0. Remember, we said this was x equals a, was the formula for a vertical line. And if a is 0, it's a vertical line, which is, in a sense, the y-axis. So there's a couple of things then about this basic equation. Now, rather than draw this again, we can now think of it sidewards here, and we want to look at our values. So here, if x is a negative 2, negative 2 squared is 4. 4 times 4 is 16. If we square negative 1, we get 1. 1 times 4 is 4. And that's the point that they're actually showing there. The 16 is way up there somewhere. And then it's symmetric also, that it goes to 0, and then it will go to a 4 here, and then it will go to a 16 way up here. So in comparing then the two formula, what do we notice? Well, if we were to put this on this graph, notice when we had 1, it would be 1 times 4. These points are there. So to sort of sketch this in a little bit, this would go up like so, and eventually up to 16, and I'm not doing this very well. This would go up so. So you can see if we superimpose this on this grid, or if we did the other one here, maybe that's easier, that this line here, as the coefficient of our x squared gets larger, it brings this line in closer to the y-axis, which is our axis of symmetry, and the equation of which is still x equals 0. Now, let's take a look at our next one here, and the obvious difference is that we have, again, this could be y is equal to a negative value. So again, when we were to plot these points, instead of all of these being positive as we see over here, all of these are negative. So when we plot a quadratic equation and its first term, the letter a, because in a sense out here, this is our a term right there, and ax squared plus bx plus c, we don't have this part, we just have this part. Our a term is negative. And you might say, will this always happen when our a term is negative, that the parabola, in a sense, opens downward? And the answer is yes. If the a term is positive, our parabola opens upwards. All right, now we'll be mentioning a few other things as we go on. And in the text, they do describe a parabola and give you some of the comments that I've talked about already. Now, one thing I failed to mention, which is a very important item, so the text does cover various items of a parabola, whether it opens upward or downward, and that has to do with our value of a. Another thing I didn't mention before is the idea of a vertex. Now the vertex for all of the ones we've done so far was 0, 0. It was the lowest point of our parabola. And if a was positive, the low point, the vertex, we refer to as the minimum. And if a were negative, the vertex is the maximum. Some of the things we'll be going over. And we did talk about the axis of the parabola. And in this case, it was the axis of symmetry. We described that already. And it was the y-axis, which the equation of the y-axis is x equals 0. This is a vertical line, which is the y-axis. Now there are other ways to write the quadratic equation, and this happens to be one here, but they're asking us first to show that this function is a quadratic function. Well, if we square this binomial, we get this trinomial, and then if we multiply each term by 2, we get this, and then if we combine like terms here, we get this. So now this would be in the standard form of the quadratic equation. And if this were 0, of course we could find solutions. And what is our a value here? Our a value is a positive 2. So this would be a parabola that opens upwards. Now they're also asking, show that the vertex of this graph, when it's in this form, is 3, 1. Now here they're describing the procedure for proving that 3, 1, which sort of comes out of this special formula here. The opposite sign of what we find there is 3 and then 1. That this is the vertex. Well, you may or may not recall that to find the vertex of a parabola, if we use negative b over 2a from our quadratic formula, our a will be 2, our b is negative 12. So substituting, we get this. This will then be 12 divided by 4, which is 3. So we verify this, and our 1 happens to be the actual vertex. Now as we look at this, in the graph in letter C, if we make a t-chart, put some points in there, that's what we get. And again, our lowest point is the vertex 3, 1. Now, what is our axis of symmetry here? Well, notice it's this dotted line, which if we put it in our formula for a vertical line, which is x equals a, what is our a value here? It is 3. So x equals 3 is our axis of symmetry, and our vertex is 3, 1. Now this leads then from this algebraic expression or function notation to a generalized formula, which is f of x equals a times x minus h, the quantity squared, plus k. Now we think of this as the vertex general formula, where k will be our y value of the vertex, and h is going to be our x value of the vertex. Now notice the way it's written here, negative h. Now if h, as we had said, was a 3, a positive 3, then when we put that positive 3 into this formula, it becomes, as we see it here, a negative 3. It's the opposite of a positive. Now, another variation of this, while we're here, if this, instead of reading like x minus 3, was x plus 3 in there, the value of 3 as a vertex point would have been originally a negative 3, comma 1. So we're seeing a little bit of difference here. And the general easy rule of this, if this is a negative 3 here as it shows, it comes out as a positive. If this were a positive 3, as we're just illustrating, the background of it would have been the negative from this formula, and the negative of the coordinate would have made this a positive. So this would come out, when we put it in its vertex form, an ordered pair, as a negative 3, the opposite sign of this. So here it's as a negative 3, comes out as positive. If it were like this, it would have come out as a negative. So we're going to see that as we look at this, and this is a formula you should be familiar with. Now, let's also mention that while we're here, whatever the x value of your vertex is, which in this case was a positive 3, that is also your axis of symmetry. There's a couple of things we're going over. In example 3 now, we're taking a look at this. They're asking us to determine algebraically whether a given parabola opens upward or downward. Well, what did we say was our a value? Our a value was negative 3 here. If our a value was a negative, we said, it opens downward. And looking at it this way, we are to determine what our vertex is. Well, we said h, comma k is our vertex. So k is going to be a negative 7, which is our y value, and the opposite sign of negative 4, which will be 4. There's our vertex. And we see that here. Now, as we look at letter B, again, it's in this vertex formula. What will our vertex be? Well, our k value is 5, and our h value is the opposite sign of this, which will be negative 3, and the text goes on to describe why that is so, which we did already on the previous slide. And what is our a value? It is positive, so it opens upwards. So in example 4, we're asked to find the rule of the quadratic function, whose graph has the vertex of this and passes through this point. So the first thing we do is recall what is our general rule if we know the vertex. That is, we know h and k. So h is going to be 3, and k is going to be 4. So we go into our formula here, and we're going to erase the h, and we're going to erase the k, and we're going to substitute the 3 here and substitute the 4 there. And of course they have this here as well. Now we then get this is what they have right here. Well, up here. We now have one point. We know that x here, this x, is going to be a 6. And our y will be a 22 out there. So now let's rewrite this. It's 22 equals a. Now we're going to do this subtraction here, get a 3, and then we have this. So we're going to square this now, get a 9. So this is 22 equals 9 plus 4. Well, 9a, I should put the a there. And we're going to bring our 4 over to the other side. That gives us an 18. And we get 9a now equals 18. Divide both sides by 9. We get a equals 2. So now we put this back into our formula, where we now have a value for a. And there is the rule for a quadratic function whose graph is the vertex 3, 4 and passes through this point. Again, lots of algebra going on here, and of course our knowledge of this vertex formula here. Now we can take almost any equation, sometimes it's not that easy, but that's in standard form, and put it into this vertex form. And the procedure we use to do that is called completing the square, which is one of my favorites. So let's take a look at that. Now, this uses a couple of techniques we've looked at already. So I think we can all agree this is the standard form of the quadratic expression, that if this were a perfect square trinomial, could be factored into a plus b, the quantity squared. And we would square this by squaring our a term, and this would be ax here, and we would get this, ax squared. And if we multiply these two together and doubled it, we'd get this. And here our x, our a I should say, is just a 1. And then we would square this term and get our c term. Okay. So what we want to do here is convert this, and right now it's not a perfect square trinomial, into a perfect square trinomial. And we do so by taking our c term here and moving it over to the side. So we have a little room for our new c term right there. Now, the rule was to put a parenthesis and then square it, because you want to take what will become your perfect square trinomial into a binomial square. So we again squared this term to get this. We multiply this term by this term, doubled it to get our b term here, we use that negative sign there. Now, what is half of 4? Half of 4 is 2. So now if we square this, we'd get that. Multiply these two together, double it, we get this. So again, we're taking half of the negative 4 to get our negative 2. Now to get our new C term here, what do we need to do? Well, we need to square this term. Well, negative 2 times negative 2 is a positive 4. Now, we're adding sort of a 4 here. To keep this whole thing equal, we have to subtract a 4 from this, because we want to keep this original expression equal to this expression. Okay, so now we take we factor this into its binomial square, and we do our summation here, which is a negative 2. And now this is equivalent to what we originally started with. And you might say, well, we added a 4 there, but then we subtracted a 4 there. But we've put it into this special form. So now, from this, what would be our vertex? Well, we said our vertex was h, comma, k. And our k value is a negative 2. And our h value was the opposite sign of what we had here, a 2. And there's our answer. So we now have our vertex, and now from this form, they want us to graph the parabola. We make our t-chart, and then we go to town. Now, when we are doing a function that looks like this, in order to put it into this form, it's much more tedious because we have to factor out the 2 here so that it looks like so, and then do the completing the square. And here finally they are telling us what the vertex value of h, or in this case our x value, is. The vertex is x, remember, which is what h is, a negative b over 2a. And our k is just the y value. All right, you'll have some practice in this as we work on things. We wanted to show you the background of how it's derived. Let's go on to example 6 now. As we look at example 6, it says this gal opens up a microbrewery and has hired a consultant, and it says she finds her daily profit from the sale of X cases of beer are given by this. Okay, so one of the things we want to look at is what is our A value here, and it's a negative 1. So will this open upwards or will this open downwards? Well, when A is negative, we said it's going to open up downwards. And then our vertex, will that be a minimum or a maximum? Remember, if it opens up downwards, the vertex is the maximum. So we're just going to, let's define our B value here while we're here. B is going to be 120. So our formula is negative B over 2A. We have our values here. We just substitute, and we get our maximum then is 60. So if we want to find the actual y value now, we'll put it in our formula. We want to find what this is here. When x is 60, what will be our y value there? So we square this, and then it's a negative. Again, divided by a negative gave us a positive 60. So 120 times 60 with this squared, we end up with this. This is our y value. We then have our ordered pair, which is 60, 3,600. And since a was negative, it's going to look like we see a little bit coming up from the bottom. And this would be our profit function. So this is the number of cases. If we sell 60 cases of beer, we're expected to make $3,600. Now, in the previous section, we looked at the supply and demand, but now when they are in quadratic forms, that is, your letters are squared, we get parabolas. And there's our demand function, and there's our supply function. Now again, the a is a -6 here. I don't know if you can see that. So this one's going to be downward, and this is a positive a here. So this one is going to be upwards. So if you look at it in a graphic form, it looks like so. So your equilibrium point is right there, and it shows where demand and supply curves intersect at the equilibrium point. Now, if you did this algebraically, you would have y equals y, put it in a standard form of the quadratic formula, simplify it if you could. Your a is 8, your b is a +1, your c is a -75, which they're substituting, and they give you your values. We would disregard the negative, and we only use the positive value. Putting that into one of the formulas, our +3, we end up with a price then of $96. As we look at this business model of example 8, here a rental manager of small apartment complexes with 16 units has found from experience that each $40 increase in the monthly rent results in an empty apartment. That is, somebody may not want to rent at the higher price. All 16 apartments will be rented monthly, currently at $500 a month. How many $40 increases will produce maximum monthly income for the complex? So let X represent the number of $40 increases. Then the number of apartments rented will be the total apartments minus those that are left empty. Also, the monthly rent per apartment will be, of course, $500, which all of the rent, plus $40 for those that are rented and not left empty. There are X increases of $40, so that's why you get the 40X. Now the monthly income, which is given by this function, I for income, is given by this equation. So if you FOIL this, you get this, and if you put it this way, this is your trinomial. Now, there is a brute force method where you can put this into your calculator, which we're not going to be using. Now, the algebraic method of making a graph of this, now notice our A value is a negative 40. So this parabola will be opening toward the bottom, with your vertex being the maximum. And that's what they're showing here, the vertex. So maximum income occurs when X is 2. That is, you have, in a sense, the manager could charge a rent of 2 of 40s, which would be 580. That would leave 2 apartments vacant. And then we have the quadratic model, which we can use to predict future behavior. Let's take a look at it. The number of physical compact disks in millions of units shipped are given according to this table. So when they first came out, we saw that there was quite an increase over the first few years. Then there was a decrease, and then now there's very, very few, well, relatively few. That's our graph. And notice it's generally sort of an upside down shaped, very broad parabola. So we see it here, the shape of the data resembles a downward opening parabola. Use the year 2000 as a maximum. Find the quadratic model in the vertex form from this data. So let's take a look at this. We want to put it in this form, and we're saying this is our maximum right about there, which we're saying is, for our X value, a 10, and we want to get a K value now, which will be our Y, and they're saying approximately, or exactly, 943. Now, when we put that into our formula, it becomes, again, opposite sign of the 10, so that will be a negative 10, and then there's our K value. Now, we can choose any other point, and they're saying let's use 15 and 705. Well, this is going to be 705 over here, and our X value there will be 15. So this is going to end up being, let's put it over here, 705 equals A times, this is going to be a 5 squared plus 943, which we'll subtract, and we're going to get here a 25A over there. A negative 238 divided by 25 gives us this. So our formula over here then, and I'm sure they're going to show, in the vertex format would be this, and then squaring this binomial, multiplying each term by this, and then combining your like terms here, give you the rule of sale of or transport of CDs. Wow. And of course, this is the general shape that we're superimposing on the actual data, which is often done. Now, they do go into quadratic regression, which we will not be doing in our course, according to my understanding. So we'll pass this up, and we had a nice 40-minute lesson here.